Hey guys, my name is Jonathan Gorostiaga, and today I'm going to teach you about the 12 different soil orders. Jelly soils are young soils with very little profile development. They are found in cold temperatures and frozen conditions for a good chunk of the year slow down the process of its soil formation. The main takeaway from this soil order is that there always is a presence of permafrost. And permafrost is a layer of material that remains at temperatures below 0 degrees Celsius for more than 2 consecutive years. Next, we have histosols. Histosols have one or more thick layers of organic soil material. They have not developed much of the soil profile because of anaerobic environments. All histosols occur in wetland environments and are most prevalent in cold climate up to the limit of permafrost. Moving on to the next order, we got spotosols. This soil order occurs mostly in coarse textured acid-parent materials subject to radial leaching. They occur only in moist to wet areas, usually where it's cold or temperate, and also in some tropical and subtropical areas. They are mineral soils with spotted horizon, a subsurface accumulation of eluviated organic matter, and an accumulation of aluminum oxides with or without iron oxides. Coming next are andisols. Andisols are usually formed on volcanic ash and cinders deposited in recent geological times. They are commonly found near a volcano source or in areas downwind from a volcano. The main idea from this soil order is that the principal soil forming process has been the rapid transformation of volcanic ash to produce amorphous or poorly crystallized silicate minerals such as allophane and immobilite, as well as the iron oxyhydroxide ferrihydrite. Moving on, we have oxysols. This soil order is the most highly weathered soil in the classification system. They form in hot climates with year-round moist conditions, hence the native vegetation is generally tropical rainforest. The most important feature is a deep oxic subsurface horizon. Some quartz and 1-to-1 type silicate clay minerals exist, but the hydrous oxides of iron and aluminum are dominant. On to vertisols. The main soil forming process affecting vertisols is the shrinking and swelling of clay as these soils go through a period of drying and wetting. Most vertisols are dark, even blackish in color, to a depth of 1 meter or more. The high shrink and swell potential of this soil makes them extremely problematic for any kind of highway or building construction. Time for the second most common soil, aridosols. Water deficiency is a major characteristic of these soils. The soil moisture level is enough to support plant growth for no longer than 90 consecutive days. The natural vegetation is mainly scattered desert, shrubs, and short bunch grasses. Aridosols are also known to have an ochric epipedon that is generally light in color and low in organic matter. Time for altisols. The principal processes involved in forming altisols are clay mineral weathering, translocation of clays to build an argillic or candic horizon, and leaching of non-acid cations to form its profile. Most altisols have developed under moist conditions in warm to tropical climates and are known to have an ochric or umbric epipedon. They are more highly weathered and acidic than alphisols, but less acidic than spotosols and less weathered than oxysols. Now we move on to mollisols. The main process in the formation of mollisols is the gathering of calcium-rich organic matter, largely from the dense root systems of prairie grasses, to form the thick, sophomolic epipedon. The humus-rich surface horizon may extend from 60 to 80 centimeters deep. The surface horizon generally has granular or crumb structures, largely resulting from an abundance of organic matter and swelling-type clays. Next is a very familiar soil order for me, alphasols. Alphasols are more weathered than mollisols, but less so than spotosols and altisols. They are found in cool to hot humid areas as well as in the semi-arid tropics and Mediterranean climates. Most often, alphasols develop under native deciduous forests, although in some cases, as in California and parts of Africa, savanna is the native vegetation. Clay skins or other signs of clay movement are commonly present in a B horizon. Due to its abundance in Minnesota, I was able to go out and dig some of this soil type up. I used a common soil digging tool to get a closer look. On closer inspection, we can see that the soil crumbles and is harder than the mollisol soil order. We can also see that the distinguishable brown ochric epipedon color from the soil. Now that we've finished alpha soils, we have 2 more soil orders left to talk about. We've made it to the baby soil order, or inceptisols. The most common characteristic of this soil is the inception of AB horizon is evident. Well-defined profile characteristics of soils thought to be more mature have not yet developed in this order. The epipedon in most inceptisols is an ocric, although plagan or weakly expressed molic or umbric epipedon may be present. Lastly, we have the largely distributed entisols. This soil order is the most weakly developed mineral soil without natural genetic B horizons. Most have an ocric epipedon and a few have a human-made anthropic or agric epipedons. Soil productivity ranges from very high for certain entisols formed in recent alluvium to very low for those forming in shifting sand or steep rocky slopes. With that, this concludes the 12 soil orders. I hope you learned something today and enjoyed the video. Thanks for watching.